Okay, so let's talk about testing our hypothesis. So we already know a hypothesis is written with its prediction with an if-then format, and now we want to test this hypothesis. So what we're going to do is we're going to create an experiment. And an experiment is just a repeatable test or manipulation, right, of whatever we're looking at. So let's just create an experiment now. Let's say I have some radish seeds and I want to see how fertilizer is going to affect these radish seeds. So I'm just going to say fertilizer. Is it good? Is it bad? Question mark. Okay, so what's going on with the fertilizer? I just realized that my radish seeds is outside of my screen, so I will write it under here. So sorry. Still getting used to all of this new technology. It's fabulous, but still figuring it out. So I got radish seeds, and I want to know how the fertilizer affects them. So I'm just going to quickly come up with my hypothesis, which is going to be if the fertilizer helps the plants or helps the radish seeds, then the plants will grow taller. Okay, so I've got my if, and I've got my then, and those are going to become important in a minute. So if we talk about this experiment, let's just quickly come up with 3 different groups that we're going to have in this experiment. The first one is going to be watered with 100% water. The second one is going to be watered with a 10% fertilizer solution. It doesn't really matter what these numbers are, but this is what we're going to do. And then the third is going to be a 1% fertilizer solution. Okay, so if we look at this experimental group, we have 2 different groups. We have what's a control group, and we also have the experimental group. Okay, so the control group is going to be the one that is under normal conditions, one that we expect to grow. Okay, and that's going to be this one, the one that's going to be watered with 100% fertilizer. That's our control group. And then this 10% fertilizer and 1% fertilizer, those are both going to be experimental groups because we don't know what's going to happen with those. So those are our experiments. Now I can have as many experimental groups as I would like. Just for the sake of keeping this fairly simple, thought I would just have 2. So those are both experimental groups. Okay. Now there is 2 very important variables, really 3, but we'll talk about 2 first, and then we'll go back to the third one. 2 very important types of variables that are in an experiment. One is the independent variable, and that's the variable that a scientist is going to manipulate. It's also going to be the variable that comes after the if in the prediction or the hypothesis. Okay, so this is after the if. So in this case, the independent variable, or the one that we're changing, right, the one that the scientist is manipulating by changing its 10% or 1% solution, what we're manipulating is the fertilizer. Okay, so our independent variable here is going to be the fertilizer. Now, the dependent variable is going to be the one that comes after the then, sorry. And it's basically the response to the independent variable. I like to say that it's what's being measured. Okay, so what is being measured? So in this case, what I'm measuring is the height of the plants. So the dependent variable in this case is going to be the height of the plants. I can get specific and say radish seeds, but I hope you get what I'm saying. The height of the plants is what we're looking at. So in this experiment, I have a control group, which is my 100% water. I have two experimental groups, which are my 10% fertilizer and 1% fertilizer groups. I have my independent variable, which is the fertilizer. It's what I'm manipulating, what I'm monkeying around with, what I'm changing the concentration of. And then I have my dependent variable, which is dependent on the independent variable. So the height of my plants is dependent on the fertilizer, whether or not it's beneficial or not. And that is going to be my dependent variable. There is a third type of variable that is not listed on this slide, but that third type of variable is going to be control variables. Now, control variables are very different from a control group. If you remember, a control group is one that is going to be grown in standard conditions, like growing a plant in water or growing a plant in soil but watered with plain water. My control variables are variables that are going to remain the same across all the groups, the control as well as the experimental groups. So these are variables that remain the same across all groups. Now, why is that so important? Well, I can't test the efficacy or the effectiveness of a fertilizer if I'm growing two different types of plants, right? I can't put radishes in the 100% water group and cucumber seeds in the 10% fertilizer and watermelon seeds in the 1% fertilizer because I don't have anything, I can't compare them. They all have different growth rates, different growing conditions, and different needs. So I can't compare which one of these three is the best. Okay, so control variables are important to remain across all three groups so that I can only be looking at the effect of the independent variable. I don't want to grow one of the seeds in a really large vessel and one of the seeds in a very small vessel. I want them to all be grown in the same container with the same amount of water, well, the same amount of volume of their solutions, the same amount of sunlight, same availability to, oxygen and all of that. So some of the things that are control variables are the seeds themselves. So we use the same seeds, the container we grow the plants in, okay, the amount of watering, so that accounts for whether or not they're water or with fertilizer, but the same amount. So if I give one of the groups, or if I give the control group, let's say 5 mLs of water, I'm also going to give the second group, the 10% fertilizer group, 5 mLs of that solution so that it's the same across the board. Another really good one to pay attention to is amount of sunlight. Because the plants, of course, require sunlight in order to photosynthesize, in order to get bigger and taller and to produce their fruits and vegetables. So if I give them a differential amount of sunlight, then that's not going to be a good comparison. Now, there are experiments that will test the effect of sunlight on plants. Of course, we all know that the plants need sun in order to survive, some more than others. But in this particular experiment, we are not changing or looking at the amount of sunlight as an independent variable. We're just looking at the fertilizer as its independent variable. Okay, so really quickly, independent variable is what we're manipulating. It comes after the if. Dependent variable is after the then, and it's what we're measuring. In this case, it's the height of the plants. Control variables remain the same across all of the groups. The control group is the one that is grown in normal growing conditions, and the experimental group or groups are the ones that are showcasing or using the independent variable. Okay, if you have questions, send me an email. Otherwise, save this slide and this lecture for future use on exams and, of course, quizzes. Take care.